In this video, we're going to learn how to name binary inorganic compounds. What do I mean by binary inorganic compound in this? I mean those inorganic compounds consisting of only two different elements with the sum of their charges being equal to 0. Apart from water, ammonia, hydrazine, as you can see the chemical formula on the screen, most of the inorganic binary compounds will end in IDE. And these inorganic compounds are divided into two equal parts, the highly electropositive and the highly electronegative. Example, we can use something like sodium and chlorine coming together to form sodium chloride. Sodium here is the highly electropositive and chlorine here is the highly electronegative. The highly electronegative will change its name from what it used to be and end in IDE, as you can see in carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, bromine, iodine on the screen. And all group 1 to 3, including scandium, zinc, silver, will retain their name. That is, you are not going to change its name, valency, and charges, with no stating of their oxidation state. You're not going to tell us it's aluminum 2, zinc 2, scandium 3. Just call it scandium oxide, scandium fluoride, zinc chloride. You are not going to tell us it's scandium 3 chloride. I hope you get me on that. But if it is not found in group 1, not group 2, not 3, and it is not scandium, zinc, or silver, you can insert the oxidation state. It is a must you insert it. You're going to insert the oxidation state using the Roman figure and written in closed brackets. The oxidation state of the highly electronegative elements are the same with their possible ionic charges. So all these carbon, nitrogen, oxygen, fluorine, their oxidation state is the same thing as their charges, as you can see here. So we have AlCl3. Al is aluminium and the Cl is chlorine, and the chlorine will change to become chloride. And you know that aluminium is found in group 3, so we are not going to name it any other thing rather than aluminium chloride, ignoring that 3 that is found at the chlorine side. So let's try that with N2O5. You know, N2O5, nitrogen here is not found in group 1, not found in group 2, not found in group 3. So we need to find its oxidation states. And this O is oxygen, and the oxidation state here is -2. And its other name now becomes oxide. So we need to find the oxidation state, knowing that the summation of charge of ions in a compound is equal to 0. And 2n plus 5O will give us 0. Where the O here is -2. So we have 2n plus 5 times -2 will give us 0. So 5 times -2 is -10. 2n plus -10 will give us 0. And 2n minus 10 will give us 0. And 2n is equal to plus 10. Divide both sides by 2, we will have n to be 5. So the oxidation state of nitrogen here is 5. So we name the compound nitrogen 5 oxide. If you think you understood what I just did, please try the following works for me. Write the answer on the comment section for me, and I'm going to tell you whether you get it correctly or not. Thank you very much for watching this video to this extent.